Welcome back to PrepForge. This is the first of 3 episodes on containers. Today, Docker. Next, Kubernetes. And finally, Docker Swarm. If you've ever heard the phrase, well, it works on my machine, Docker is the technology that finally makes that sentence obsolete. Here's the one-line pitch. Docker packages your application and everything it needs to run into a single, portable unit called a container, so it runs exactly the same way on your laptop, in testing, and in production. In this video, we'll cover containers versus virtual machines, images, and layers, the Dockerfile, registries, volumes, networking, and Docker Compose. Study it and you'll understand how a container actually works. Let's get started. Let's start with the problem Docker solves. You build an application on your laptop, and it works perfectly. You hand it to a teammate or deploy it to a server, and it breaks. Why? Because their environment is different. A different operating system, a different version of Node or Python, a missing library, a different configuration. This is dependency hell, and the classic excuse, it works on my machine. The old fixes were painful, long setup documents, or heavyweight virtual machines. Docker's answer is elegant. Package the application together with its exact runtime, libraries, and settings into one container. Then that container runs identically everywhere because it carries its whole environment with it. Concept 1. Containers versus virtual machines. So what exactly is a container, and how is it different from a virtual machine? A virtual machine virtualizes the hardware. Each VM runs a full guest operating system on top of a hypervisor, so 3 apps means 3 complete operating systems, which is heavy, gigabytes of memory, and slow to boot. A container virtualizes the operating system instead. All containers share the host's single operating system kernel, and each one packages just the app and its dependencies. So a container is megabytes, not gigabytes, and it starts in milliseconds, not minutes. The trade: VMs gives stronger isolation, containers give far more speed and density. For most applications, containers win. Concept 2. Images and layers. A container starts from an image. An image is a read-only template, a snapshot of a file system with your app and everything it needs. The clever part is that an image is built in layers. Each instruction, the base operating system, the installed dependencies, your application code, becomes its own stacked, read-only layer. Layers are cached and shared, so if 10 images all use the same base layer, that layer is stored once. And when you rebuild after changing only your code, Docker reuses every cached layer below and only rebuilds the top. When you run an image, Docker adds a thin writable layer on top, and that's your running container. Concept 3. The Dockerfile. How do you create an image? With a Dockerfile, a simple text recipe. Each line is an instruction that becomes a layer. From picks a base image, like a small node image. Work your sets the working directory. Copy brings your files in. RUN executes a command, like installing dependencies. Expose documents the port. And CMD defines the command that runs when the container starts. You run Docker build on this file, and Docker executes each step, producing your image. The Dockerfile is the single source of truth for how your app is packaged, checked into version control, right next to your code. Concept 4. Running containers. Now let's run it. The command docker run takes an image and starts a container from it, a live, running instance of that image. You can run many containers from the same image, each isolated from the others. A container has a lifecycle. It's created, then running, and you can stop it, start it again, or remove it entirely. Here's the important mindset. Containers are meant to be ephemeral, disposable. You don't log in and tweak a running container. If something needs to change, you change the Dockerfile, rebuild the image, and start a fresh container. Treat them as cattle, not pets. Concept 5. Registries. How do you share an image or get it to a server? Through a registry, a store for images. The best known is Docker Hub, but companies run private registries too. The flow is simple. You build your image, tag it with a name, and Docker push it to the registry. Then, on any other machine, a server, a colleague's laptop, a build pipeline, you Docker pull that exact image and run it. This is the heart of Docker's portability. The identical, versioned image you tested is the one that runs in production. No rebuilding, no drift. Concept 6. Volumes. There's a catch with that disposable nature. When you remove a container, everything written inside it is gone. So where does data that must survive? Like a database's files, live in a volume. A volume is storage that Docker manages on the host and mounts into the container, but its life cycle is independent of the container. The container can be destroyed and recreated, and the volume and its data remain. The rule: keep your containers stateless and put all persistent data in volumes. Never store important data inside the container's own writable layer. Concept 7. Networking and ports. By default, a container is isolated with its own private network. Two things make it useful. First, port mapping. Your app might listen on port 3000 inside the container, but that's hidden. With Docker run-p, you map a host port to the container port, say host port 8000 to container port 3000, so the outside world can reach it. Second, Docker networks. Containers on the same user-defined network can talk to each other by name. So your web container can reach your database container just by using the name database. No IP address is needed. That name-based discovery is how multi-container apps wire together. Concept 8. Docker Compose. Real applications aren't one container, there are several: a web server, a database, a cache. Starting and wiring those up by hand is tedious. Docker Compose fixes that. You describe your whole application, every service, its image, ports, volumes, and networks in a single YAML file, docker-compose.iml. Then one command, Docker Compose up, starts everything connected and configured. It's the easy way to run a multi-container app on a single machine, and it's perfect for local development. Keep this in mind, because it's the natural bridge to our next episode. When you need to run these containers across many machines reliably and at scale, that's where Kubernetes and Docker Swarm come in. Concept 9. Best practices and when Docker is the right tool. A few best practices that make real experience. Use small base images, like the Alpine or Slim variants, for faster build and smaller attack surface. Use a .dockerignore file to keep junk out of your image. Run one process per container. One job, one container. Use multi-stage builds to compile in one stage and ship only the result, keeping images tiny. And as we said, keep containers stateless, data goes in volumes. Said simply, Docker packages your app with its entire environment so it runs the same everywhere. Explain the container versus VM difference and the build, push, pull flow, and you've shown you truly understand it. And that's Docker, end-to-end. Containers that share the host kernel, so they're light and fast, built from layered, read-only images defined by a Dockerfile, shared through registries with persistent data in volumes, and services wired together by Docker Compose. It's how you make it works on my machine, true everywhere, but Docker runs containers on one machine. In the next episode, we'll scale to thousands of containers across a whole cluster with Kubernetes. If this helped, subscribe. Kubernetes is next. Thanks for watching, and good luck in your interview.